Leica is an award-winning production company located in Oregon best known for stop-motion animation films such as Coraline, Paranorman, and The Box Trolls. As one of the earliest filmmaking techniques, stop-motion animation is captured one frame at a time, with physical objects that are moved between images. When you quickly play back the sequence of images, it creates the illusion of movement. Leica transforms a 2D character image into a 3D puppet with natural movement, using a metal skeleton armature with joints for posing. The puppet's outer parts are molded in silicone, and other details are hand-assembled. At Penn State, our team is tasked with exploring different lattice structures and determining the possibilities they bring to Leica puppets for stop-motion filmmaking. Lattice structures are interconnected open unit cell structures that can significantly reduce weight while maintaining strength. They are well suited for puppets due to their versatility to create precise complex geometries that allow for customization to fit specific mechanical needs. We use software called N-topology to create forms and apply lattices. We began experimenting with different lattices in a basic pill-shaped form. Then, we experimented with combining lattices in a singular form and also varying the thickness of the lattice. Throughout our experiments, we found that the reentrant honeycomb lattice stand out because of its unique ability to twist and bend. With these properties in mind, we chose to replicate a puppet arm, which required the movement that this lattice could help facilitate. We worked through a series of arm prototypes before settling on a final puppet arm. The arm was modeled in N-top using basic forms of cylinders, cones, and spheres. The reentrant honeycomb lattice was applied to the arm, keeping the wall thickness smaller in areas that required more movement like the wrist and elbow. A gradient of thickness was used to reach stiffer sections like the forearm and upper arm. 2 holes were created through the center of the arm so that a makeshift armature could be placed. Throughout the project, we utilized the Stratasys J55 resin printer to print parts with the flexible resin elastico. Once parts were printed, they were placed in a water bath to remove support material. Once the support material was dissolved, the parts were taken out of the bath and allowed to dry. The metal armature was placed inside the arm to hold its position once moved between frames. To test how this lattice helped facilitate natural arm movement, we used video tracking software and printed a solid elastico material arm and a latticed arm, and compared angles of rotation and flexion against human arm values. The latticed arm was in close range with human values and performed much better than the solid arm, proving that lattices help facilitate natural movement for puppet parts. In closing, we filmed a few seconds showing the rotation and flexion of our puppet arm in stop-motion animation.